Hi, everyone. Today we're going to talk about our interval notation with our inequalities and talking about different ways that we can represent our answers with inequalities. So the first thing we need to do is we need to talk about what are the symbols that represent our inequalities. So our less than symbol, remember, looks like an L. Our greater than, the opposite. Less than or equal to, having a little part of the equal sign underneath it. Greater than or equal to, and then also not equal to. So for not equal, an equal sign with a slash through it. So I might say something to you like x is less than 3. So if I was on a number line, right, so let's say I had the numbers 2, 3, and 4, what I'm saying is that my answer can be any number up to 3, not including it, and less than, right? So I would shade to the left, all of the numbers less than. So the way that I could write that in my interval notation, okay, so my interval would say, hey, I'm going all the way from the left. I can go forever and ever towards infinity, so negative infinity, all the way up to 3. Now I'm using an open bracket because I have an open circle. It can get very, very close to 3, but can never equal 3. Now my set notation here, this would say the set of x's, and that little line means such that. And then we're going to put something after it. So in this case, I would make these curly French brackets, the set of x's such that x is less than 3. Now I like to remember set notation has the squiggle. All right, so set has the squiggle. All right, so if I had a greater than, okay, so let's say that I wanted to say that x was greater than 3. So again, on my number line, I'd have 2, 3, and 4. And I'd again have an open circle because I couldn't be 3, but I can be anything larger than 3. So again, my interval goes from low to high. So in this case, I'd say, all right, I can start at 3, and I'm going to go towards infinity. My set notation, okay, so again, my French brackets, the set of x's such that x is greater than 3. Okay, less than or equal to. So for less than or equal to, very similar, x is less than or equal to 3. So this time we're saying, all right, my solution can be anything 3, so I'm going to fill that circle in, or less. So notice that my circle now is filled in. So because my circle is filled in, I'm also going to say negative infinity. And when I include my 3, I use a little square bracket, right? So my square bracket means it can be included. All right. Oh, let's finish that one. So my set notation, again, with my squiggles, the set of x's such that x is less than or equal to 3. All right, greater than or equal to. So if I want to say x is greater than or equal to 3. Okay, again, 3 on my number line. So since it can equal 3, I'm going to put a closed circle, and I want all the numbers greater than. So again, for my interval, going low to high, my lowest value on that picture is 3, and I'm using a square bracket because that's filled in, and I go all the way to infinity. And infinities always get a parenthesis because infinity is not a number, it's a concept. All right, so then my set of x's such that x is greater than or equal to 3. All right, and last one. Now this one you might not have seen. So if I want to say x is not equal to 3, right, So I've got 2, 3, 4. So what I'm saying is that x can be any number in the whole world except 3. So this actually is going to have 2 intervals to it. So we're going to say that we're going from negative infinity to 3, and I'm going to union that with 3 to infinity. So that right there means union. And for my set notation, I'm just copying my example. So the set of x's such that x is not equal to 3. So when I'm solving problems that have inequalities in them, I'm going to solve the inequality. I'm going to write it in interval notation and then write it in set notation. So for question 1, I'm going to subtract 2 from both sides. So I have a is less than or equal to negative 7. So I have my inequality. I'm going to graph my inequality on a number line. So I'd have negative 8, negative 7, negative 6. And this here would be a closed circle since I am a less than or equal to. And since we are less than, we are shading to the left. So my interval would be from negative infinity to negative 7, and I am including the negative 7, so closed circle, closed bracket. And then my set notation, so squiggly brackets, French brackets. Now this time I don't have an x in the problem, I have an a. So the set of a's such that a is less than or equal to negative 7. Number 2. So in number 2, I'm going to add 0.3 to both sides. So now I have c is greater than 4.8. So again, I'm going to make myself a number line. And since this is a decimal, right, let's maybe use 4.7, 4.8, 4.9. So since this is a greater than, we are going to use an open circle. And we're going to shade everything that is bigger. So my interval notation, I'm starting at 4.8 as my low. I'm going to infinity as my high. And my set notation, the set of c's, such that c is greater than 4.8. All right, moving on to a couple more problems. Number 3. So number 3, I've got x divided by 4. So I'm going to multiply both sides by 4, and I have x is greater than negative 8. So I make a number line, negative 9, negative 8, negative 7. This is a greater than, so open circle, and we are going to shade to the right. And so my interval, we'll say open, right? Open bracket there. So negative 8 all the way to infinity. My set notation, the set of x's, such that x is greater than negative 8. All right, let's try number 4. And something tricky about number 4. So in number 4, we are dividing both sides by negative 5. And if you remember from middle school, when you multiply or divide both sides of an inequality, by a negative, we need to switch the inequality sign. So right here, dividing both by a negative, I now have x is less than or equal to, right, flipping that around, to -3. So I'm going to put that in a number line. So -4, -3, -2. We're going to make sure that that is a closed circle. And I want all of the things that are to the left. So my interval will go from -infinity all the way to -3 inclusive, so including that. And my set notation, my set of x's, such that x is less than or equal to -3. All right, why don't we get started on a couple of the next problems, and I want you to try those on your own.